Just like with multiplying rational expressions, I think it's best to start out by doing a regular fraction example like you would see in algebra, middle school, something like that. Remember, when we divide two fractions, the little phrase I taught you guys, or the way that I was always taught how to do these, keep, change, flip. That's what happens when you divide a fraction, divide by a fraction, I should say. Keep, change, flip right here. You keep the first fraction the same, so it'd be 4 over 6. You change your sign to multiply right here, and you flip the second fraction. So you're going to multiply by the reciprocal, essentially. And once you flip that guy, you're basically just doing a problem like in our last video. You can multiply straight across. Now I want to get a little bit fancier on this problem here to show you a trick similar to what I did in the last video. Just like we were able to cancel things on one on top, one on the bottom, they're going to reduce later on. Instead of multiplying right now, you're more than welcome to do that. I see I have a 12 on top and a 6 on the bottom. I'm going to turn this 12 into a 2 and this 6 into a 1. So I'm reducing this part before I multiply them because it's going to make my job a lot easier. Then instead of getting 48 over 18 and reducing it, I'm just going to get 8 over 3. So I can get to my final answer a little faster by doing it that way, although it isn't necessary to set it up like I did. So, same principle applies to this other problem right here when we have variables involved. Keep the first fraction the same. So we got x plus 11 over x minus 2. Change the sign to multiply and flip the second fraction over. So now the x plus 5 is on top, and these two guys, x minus 4 and x plus 11, are on the bottom. So, it's a little bit annoying to have to rewrite this, yes, but it makes your job a lot easier. We can see that there's an x plus 11 and an x plus 11 that are going to cancel, and there's nothing else that can be done at this point. No other terms that are the same. So I'm just going to write my final answer here. It'd be x plus 5 over, I have an x minus 2 and an x minus 4. And I'm just going to leave it in that form. You could multiply them out, but you don't have to, unless the problem says specifically they want it in standard form or something like that. Now, excluded values are a bit more complicated, not complicated, but a bit more work here, because you have to look everywhere, across the entire problem. Anywhere you had a variable in the denominator, you got to make sure it doesn't equal 0. So I need to say x can't equal 2 from this parenthesis right here. I need to do it for this parenthesis, even though it eventually got flipped into the top. That's still important here. X can't equal negative 5. I have x can't equal 4. And x can't equal negative 11. So there were quite a few excluded values in that problem just due to how it was set up. And in our last problem of the video here, again, if you see terms like this, where you've got a lot going on, you should try to factor it first. It just makes your job so much easier. And skipping the work on that, this guy turns into x plus 2 times x plus 3. This guy's going to be x plus 6 times x plus 6. This guy, it's x plus 3 squared, so I'm just going to write it out as x plus 3 twice. And when I do my keep, change, flip, that's going to be kind of a pain here. So I'm going to take a little lazy shortcut. I'm not going to bother rewriting the first guy. I'm just going to cross this guy out and flip him over. So what I end up with is 5 over x plus 3, x plus 3. If this bothers you, just rewrite it and it'll be fine. But I flipped it on my own instead of rewriting the entire problem. I see I have matching x plus 3's, top and bottom. That's it. Everything else is different. I have an x plus 2 and a 5 on top. So I have 5, and then I have my x plus 2. On the bottom, I have x plus 6 twice. So I'm going to go ahead and write that as just x plus 6 squared. It'd be easier that way. And I have a leftover x plus 3. There's a lot going on in this one, but the math behind it, you're just canceling stuff that matches. For my excluded values here, we're looking at x can't equal negative 6, and x can't equal negative 3.